Hi everyone, today we're going to look at operations with functions. So the operations we're going to be looking at is adding, subtracting, multiplying, and dividing. So looking at our first one, we have f plus g of x can be written as f of x plus g of x. So this is one way to write it, and here is another way to represent the exact same operation. Subtracting functions, f minus g of x is equal to f of x minus g of x. Multiplying, we have f times g of x. That can be written as f of x times g of x. Now these square brackets are just another way to say that it's this function contained in the square bracket times the other one. But it would be reasonable to just write f of x times g of x. And dividing, we have f divided by g of x is the same as f of x divided by g of x. And that, of course, as long as g of x does not equal 0. So let's look at a few examples how we would work with operations with functions. All right, the first example is adding. So we are actually given the first function f of x, and it is given as x minus 5. And our second function, g of x, is given as x squared minus 2x minus 15. Now we are asked to find f plus g of x. Well, that is equivalent to f of x plus g of x. Well, what is f of x? Well, if you look at our function, f of x is just x minus 5. So I can substitute x minus 5 right here for f of x. Plus g of x. What is g of x? X squared minus 2x minus 15. So I'm going to rewrite it here. X squared minus 2x minus 15. Once you have written down your two functions, and we are adding both of them, all you need to do is combine like terms. So I like to circle starting with the highest degree first and combine like terms. So I can see that x squared right here is my highest degree, and there's no other x squared term, so I'm going to rewrite that first. I kind of like to cross it out or highlight knowing I've already used it. And then the next highest term is an x. So I have an x here, and I'm going to combine it with negative 2x. X minus 2x is negative x. And we have completed those. And lastly, I'm going to combine my constants, which is negative 5 plus negative 15. Now be careful, you don't want to forget that this is a negative, so make sure you are combining two negatives. So negative 5 minus 15 is negative 20. So this would be our final answer for this example. All right, let's look at a subtraction example. So we're going to take the same two functions, but now we are going to subtract them. So we have g minus f of x. So this is the order in which they want us to subtract the function. So this means g of x minus f of x. So I'm going to take the first function, g of x, and that is given up here. G of x is x squared minus 2x minus 15. So I'm going to write x squared minus 2x minus 15. And then I'm going to bring down this negative. So all of this here is g of x. Okay? All of this is g of x. Now I'm going to subtract. And I'm going to put f of x in parentheses because I'm going to subtract all of f of x. And f of x happens to be x minus 5. So because it is more than one number, it is a binomial, I want to make sure that I distribute this negative. So we're going to first simplify and then combine like terms. So removing this parenthesis, this is the same as having a 1 in the front, so it stays the same. This is still x squared minus 2x minus 15. Now be careful here when I subtract the x, it becomes negative x, or it's the same as a negative 1 in the front. So this becomes negative x, and then minus 1 minus 5 becomes plus 5. So be careful. This is where students will likely make a mistake. This negative also is distributed to the second term. So after we have done that, we basically will add all our terms just like we did in the first example. But we're going to take our highest degree, so that is x squared. And there's no other x squared term, so I'm going to write that down. And then I'm going to look at my next highest term, which is negative 2x and minus x. Negative 2x minus x is minus 3x. And then negative 15 plus 5 is negative 10. So our answer to g of x minus f of x is x squared minus 3x minus 10. Okay, moving along to multiplication. We are going to take now the two functions and we're asked to multiply them. So f times g of x is the same thing as f of x times g of x. So basically I'm going to write down my first function, which is f of x, is x minus 5, times g of x is x squared minus 2x minus 15. But we're not done yet because now we need to distribute and combine like terms. So the first term's multiplied, x times x squared is x cubed. X times negative 2x is negative 2x squared. Be careful here. Make sure when you're multiplying that you are adding exponents. So anything that doesn't have an exponent is actually an exponent 1. All right, so we did the first two. X times negative 15 is negative 15x. So we did x times all these three terms. Now we're going to do negative 5 times all the three terms. So negative 5 times x squared is negative 5x squared. I kind of like to already place them with like terms, so then when we're adding them, it's easier to combine. Negative 5 times negative 2x, and be careful, this is a negative times a negative, is plus 10x. And then negative 5 times negative 15 is positive 75. Okay, but we're not done yet. Now we're going to combine like terms. So I have my x cubed. That is the only degree 3 term, so I will rewrite it as x cubed. Then I'm going to combine my degree 2 polynomials, so that is negative 7x squared. I'm going to combine these two terms, negative 15 and 10x is negative 5x. And then we are left with positive 75. So this would be how we multiply and then combine like terms. So remember the distribution here. First term multiplies all the three terms here. Second term multiplies all the three terms here. Kind of looks like a little fish with all the scales. Put the eye here, little happy face. All right, lastly, we're going to look at division. So dividing is basically just putting the numerator over the denominator and seeing if there's anything you can reduce. So this actually means take f of x and divide it by g of x. And of course, we want to make sure g of x is not equal 0, but we do not know what our x terms are. So you do not need to worry about that. All right, what is f of x? Well, I'm going to look at the function here. It's x minus 5. So I will write x minus 5. What is g of x? g of x is x squared minus 2x minus 15. Now, if we can reduce this fraction, we should reduce it. If we cannot reduce it, then we just leave it as is. So how do we know if we can reduce it? Well, the top one is just x minus 5, but I'm going to see if I can factor the trinomial on the bottom. So in other words, are there two numbers that give me negative 15 when I add gives me negative 2? And I'm going to see, actually, the only way this cancels is if one of the factors is x minus 5. So I'm going to see I have if that works out. And indeed, negative 5 times 3 is negative 15, and negative 5 plus 3 is negative 2. So actually, I can rewrite this as x minus 5 times x plus 3. And then what are our common factors? Well, x minus 5 can cancel. Now be careful. What am I left with in the numerator? Because you don't see anything, it doesn't mean it's 0. So if you said you are left with 1, you are correct. So our final answer is 1 over x plus 3. Now to take it one step further, if you recall, we said where g of x cannot equal to 0. Well, what would make this whole function here equal to 0? Well, if we factor it, we can see what would make it 0 is that if x were to equal 5 and x were to equal negative 3. So they cannot equal those numbers. So x cannot equal 5 and x cannot equal negative 3. We could see right here, negative 3. But in this fraction on top, we can also see the 5. And that is basically it with operations of functions.